Hello students, this is Miss Marsh. So today we're going to look at section 4.4, which is on graphing function rules. Make sure you have a notebook and a pencil today. You do not need a calculator at all. So this video is going to focus on how to graph and that represent functions. So right straight into the problems. So we need to graph this function rule, negative 2x plus 1. So I have my little chart over here. You're going to want to put the chart in, and also we're going to actually graph it. So you're going to want to make yourself a little coordinate plane in your notebook. So whenever I want to graph a function rule, I'm always going to use the numbers negative 1, 0, 1, and 2. I want some negative, 0, and some positive. So now what I need to do is plug that in for x. So I'm going to go y equals negative 2 times negative 1 plus 1. Now, negative 2 times negative 1 is 2, plus 1 gives me 3. So my coordinate point is negative 1, 3. So if I plug in 0, I get negative 2 times 0 plus 1. So I get the point 0, 1. If I plug in a positive 1, negative 2 times 1, negative 2, plus 1, negative 1. And if I finally plug in a 2, negative 4 plus 1, negative 3. Ooh, looks like I wrote that one wrong. I should have a 1 there. There we go. So now I'm going to graph those points. Negative 1, 3. So negative 1 up 3 dot 0, 1, 1, negative 1, and 2, negative 3. So then I gotta connect my line here. There we go. Made my graph. Now let's graph a real-world function rule. So the function rule W equals 146C plus 30,000 represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 feet, what is the reasonable graph of the function rule? So first of all, I need to think of some numbers because negative 2, 1 is not going to cut it since I'm talking in such big numbers. So I'm going to think, what's the lowest amount of concrete can I have? And what's the highest amount of concrete I can have? So the lowest amount of concrete. How much, the lowest amount of concrete I can have in this truck is 0, right? If I have just 0 amount of concrete, 0 cubic feet. And then the highest, it says it has a capacity of 200 feet. So I can put at most 200 in there. So now I want to probably go up by a big amount. So I'm going to go up by 50s. I think 50 looks about right. Now I could have gone up by something different, but I just wanted to go up by a pretty nice constant amount. Then I'm going to plug in my C into my equation. So I got W equals 146 times 0 plus 30,000. Now 146 times 0 is 30,000. Then I want to go to 50. So I'm going to go W equals 146 times 50 plus 30,000. So now if I did that math, 146 times 50 is 7,300. Then I'm going to add that to 30,000. So I'm going to get 37,300 for a answer. Same thing here. I'm going to do 146 times my C, which is 100. Add 30,000 on. Basically, I'm taking the value I got and plugging it in for C, substituting it. 146 times 100 is 14,600 plus 30,000. So I'm going to get 44,600. Same thing, multiply by 150. Once I did the math, I got 51,900. And finally, at capacity, the total weight of my concrete is 59,200 pounds. So now I'm going to graph this. So now it looks like I can go by 50s this way. So I'm going to go 50, 100, 150, 200, 250. Now I need to get really big numbers, so it looks like I'm going to need to either probably go by 5,000. So then this would be 10,000, 15,000, 20,000, 25,000, 30,000, 35,000, 40,000, 50,000, 55,000. Oh, messed up here. Should have 45,000 there. 45,000 right there. 50,000, 55,000, and 60,000. So at 0, I should have 30,000. So my first dot is going to be right about there. Now at 50, I get 37,300. So that's just a little bit more than 3,500, probably right in the middle around here. At 100, I have 44,600, so it's just under 45, about right there. 150 is 51,900, so just above 50,000, about right there. And about 200, I have 59,200, so just shy of 60,000. So then I'm going to connect my dots. And it looks like that is my graph. Now, some vocab that you're going to want to have down. Continuous graphs and discrete graphs. Now, if you notice, a continuous graph is a graph that is unbroken. It's just a straight line. Discrete graphs is when you have composed of distinct isolated points. Now, most graphs you're going to see are going to be continuous. This is usually when you're talking about a weight of something, because I can have 0.5s, I can have 3s, and all of that. Discrete graphs is kind of like buying shirts or buying food or something that I cannot buy a half of. I can't buy half of a shirt. So I can only buy 1 shirt, 2 shirts, 3 shirts. So I can't have a line and connecting all these dots, because then that would mean that I have a price for 3.5 shirts, which just doesn't make sense. So that's why it's a discrete graph, and it has just dots instead of lines like that. Let's graph some nonlinear functions now. So they want me to graph absolute value of x minus 4. So I'm going to make myself a t-chart that looks like this. I'm going to have an x and a y. So if I plug in x, I'm going to do -2, -1, 0, 1, and 2. Just so I get a nice graph on this. So I'm going to plug this in. I'm going to get y equals absolute value of -2 minus 4. Absolute value of -2, if you remember, absolute value makes anything positive. So I'm going to get a positive 2 out of here. So I'm going to get 2 minus 4, so that's going to give me -2. If I plug in a -1, it's going to give me positive 1 in there. Positive 1 minus 4 is a -3. If I plug in 0, I'm going to get absolute value of 0, 0, minus 4, minus 4. Plug in 1. Absolute value of a positive 1 is positive 1, minus 4, negative 3. Whoop, that should be a 2. There we go. Absolute value of positive 2 is positive 2, minus 4, negative 2. So let's graph these points. Negative 2, negative 2. Negative 1, negative 3. 0, negative 4. 1, negative 3. And 2, negative 2. Then if I connect my dots here, looks like this graph is nonlinear, just like we were asking, and it looks like it shapes a V, which is pretty cool. Let's take a look at the last problem. X squared plus 1. So I'm going to make my t-chart just like last time. So I'm going to plug in negative 2, negative 1, 0, 1, and 2. So if I plug in negative 2, I'm going to have negative 2 squared plus 1. So I just substituted it for x. So negative 2 squared, make sure if you do this on your calculator, make sure you put that in parentheses. Otherwise, you'll not get the correct answer. That is actually a positive 4, because negative 2 times negative 2 is positive 4. Add 1, that's going to give me 5. Y equals negative 1 squared plus 1. Negative 1 squared is 1 plus 1, 2. Let's plug a 0 in. 0 squared, 0, plus 1, 1. 1 squared, 1, plus 1, 2. 2 squared, 4, plus 1, 5. Now let's graph these points. Negative 2, 5. Negative 1, 2. 0, 1. 1, 2. And 2, 5. Now, unlike last time, I'm going to get what's known as a parabola. Because it's an x squared. You're always going to get a parabola graph. And we're going to look more at parabolas later in the year. So that is how you graph function rules. See you later, Sabers!